Question 14 is asking us if there are two consecutive square numbers that differ by 3,721, and if there are two consecutive triangle numbers that differ by 3,721. So to do this, we're going to start with the consecutive square numbers. We want to remember that if we have a square number, such as 9, I'm going to draw it out here, which can be drawn as 9 dots in a square, like this. We can express this in if we see the boomerangs, if you remember from your class notes. So these are given like this. So in this case, we have 1, 3, and 5. So to get our square number of 9, we're adding 1 plus 3 plus 5. So for consecutive square numbers, all you're doing is adding the next odd number in your sequence of numbers. So we can imagine that once we get really, really, really big squares, we can have a series of numbers where we have 1 plus 3 plus 5, our first odd numbers, all the way up to the odd number 3,719. And this is just going to equal some answer. You don't have to figure it out for this question. And then for our next square number, we're going to have the same thing. We're going to get all the way up to 3,719, but we're going to add the next odd number, which is 3,721. And this is going to give us another answer. We'll call it B. So you can see that between these two consecutive numbers, it's exactly the same up to 3,719, and then the difference between them is going to be 3,721. So yes, there is two consecutive square numbers that differ by 3,721. We've shown that here with just adding all these odd numbers because we know that's how we can express square numbers. So the question doesn't ask us to figure out what these square numbers are. We just have to show that with these series of numbers here, we do have a difference of 3,721 between our consecutive square numbers. So moving on to part B, so it's part A up here. We're now looking at triangular numbers and seeing if there's two consecutive ones that differ by 3,721. So with our triangle numbers, we're now putting dots in a triangle like this. This is a triangle number 6, and we can write that as, again, an addition of numbers. In this case, it's going to be 3 plus 2 plus 1 equals the triangle number 6. So we can see that as we go to the next consecutive triangle number, we're just going to add one more dot. Or sorry, one more row of dots, like this. So we're going to be adding 4 plus 3 plus 2 plus 1, in this case, is going to give us 10, which is the next triangle number. So we can see that if we get to really big triangle numbers, we can have the case where we have 1 plus 2 plus 3 all the way up to 3,720, and that's going to equal some answer. And then for the next triangle number, we're going to have the same thing, plus 3,720 But we're going to add the next number, which is going to be 3,721. And so again, in this case, we have the exact same thing up, and the only difference is this 3,721. So these two triangle numbers are going to differ by 3,721. So yes, again, there is two consecutive triangular numbers. We don't have to find them in this case, but they do exist. And yes, there are two consecutive square numbers, and they can be given by these two series of numbers here and these two down here.